Next, I want to talk about the vasoactive mediator histamine. And histamine has a big role in allergic responses. So histamine is preformed in so-called mast cells. So you can see here the little vesicles with the H in it. So this is a histamine, and that's a mast cell, a cell that you're going to learn more in immunology about. Once it's degranulate, it releases histamine. So when does it degranulate? Well, this is more immunology, but just briefly, the mast cell has so-called Fc epsilon receptors on its surface. So the epsilon comes from because they bind IgE. And so once there is some allergen that binds to this IgE, this agglomerates these IgEs, and then the cell is gonna release histamine. And these allergens could be like cat saliva, dust mite, or if somebody that has an allergy to peanut butter eats a peanut butter sandwich, this cell is going to release, this mast cell is going to release histamine. So we want to talk now about what does histamine do to the vasculature. And you probably already know that, what is a net effect. So if somebody has an anaphylactic shock, what's going to happen to blood pressure? Well, it's going to drop. The patient is going to have hypotension. And we want to now understand why the patient has hypotension. And if we are thinking about responses to the vasculature, we always want to think about vascular, smooth muscle, SM, but also about the endothelial cell. Because a lot of times, vasoactive mediators have receptors on both vascular smooth muscle cell and the endothelial cell. And that's actually the same for histamine. So the histamine receptor is the H1 receptor. It's GQ coupled, and it sits on the vascular smooth muscle cell, but also on the endothelial cell. So this is this G protein coupled receptor, GQ. And we know what happens when you stimulate a GQ coupled receptor on vascular smooth muscle cell. You're going to get more calcium. Calcium binds to calmodulin. That's going to activate myosin light chain kinase. A kinase phosphorylates. So it phosphorylates myosin light chain, and then actin can interact with it, and you're going to get vasoconstriction. But that doesn't make sense because we said the blood pressure is going to drop. Well, there's another effect that is opposing, and this is mediated by the H1 receptor on the endothelial cell. So there's also calcium influx, but endothelial cells are not equipped with myosin light chain, so different things are happening. Here, the endothelial cell, when we have increased levels of calcium, is going to make us more endothelial NO synthase. And as the name already implies, endothelial NO synthase makes us NO, this gas. And this is going to diffuse everywhere. It's a gas. So it's also going to diffuse here into the vascular smooth muscle cell. And it's going to activate soluble guanyl cyclase. What does soluble guanyl cyclase do? Well, it makes cyclic GMP from GTP, and that activates PKG, and then activates the myosin light chain phosphatase. So phosphatase cut off the phosphate, and then in the end, this leads to vasodilation. So we can see here that we have two opposing effects. So what's going to happen? Well, we know the blood pressure is going to drop. So the vasodilation here, mediated by the NO, is the winner, is the more dominant effect. So you're going to have both, but this is the one that is more prominent, and therefore your blood pressure is going to drop. So we just talked about anaphylactic shock, which is kind of the worst case scenario, but also we can think about what happens when a bee stings me. How does it look? Well, it looks red and swollen. Why? Because of vasodilation, because of exactly the same. Whereas the anaphylaxis is obviously a systemic effect. This is going to be a local effect, but that's the same scenario. You're going to have vasodilation, and that finishes the vascular response to histamine.